crater lake is a lake that forms in a volcanic crater. A well-known crater lake in the United States is located in southern Oregon and is the crown jewel of Crater Lake National Park. The water is noted for its deep blue color and attracts millions of visitors every year. Because the lake lies in a dormant volcanic plain, swimming is permitted and the water is exceptionally clear and neutral, with the average pH ranging between 7 and 8, the normal pH of fresh water. Another well-known crater lake is located in the Ijen volcano complex in Indonesia. Along with covering an active volcanic field, the lake is also the site of a sulfur mining operation, resulting in bright turquoise waters that are heavily saturated with toxic metals. It is the most acidic lake in the world, with a pH measuring from 0.5 to 0.13. That is lower than stomach acid. Despite its alarming presence of toxins and jarring appearance, the lake is safe as long as prolonged exposure to its waters is avoided. Many people call the area around the lake home, and the lake has been the site of mining operations for several decades with no issues. But for some lakes, even ones that are less obviously harmful, the dangers aren't contained within their depths, and merely existing near them is enough to put your life in danger. On the western coast of Africa, nestled between Nigeria and the Congo, is the small nation of Cameroon. The French-speaking country is widely known for its geological diversity. Despite just barely outsizing Texas, the nation boasts beaches, deserts, mountains, savannas, and even rainforests. In the western highlands of Cameroon is the Oku volcanic field, which is home to 4 major volcanoes: Mount Oku, Mount Nyos, Mount Nkambe, and Mount Babanki. Along with these volcanoes are 2 crater lakes, Lake Monon and Lake Nyos. Lake Nyos fills an explosion crater which was believed to have been formed approximately 12,000 years ago. It is one of only 3 lakes in the entire world that is saturated with carbon dioxide, which is leaked into the water by a pocket of magma which lies beneath the lake. Like most bodies of water, the waters of Lake Nyos are stratified. This means that the water is divided into layers, with warmer water staying near the surface, while colder, denser water stays at the bottom. Because of this, the carbon dioxide seeping in from the bottom of the lake is mostly contained within these deeper layers, and a significantly smaller amount of CO2 is actually able to reach the surface. Think of Lake Nyos like a can of soda. The bubbles we associate with carbonated beverages are only formed after we open the can. This is because while the can is closed, the soda is intensely pressurized. Carbon dioxide rapidly dissolves in water when it is under heavy pressure. But when the can is opened and this pressure is released, the bubbles form as the carbon dioxide rises to the surface. Similarly, the deeper you dive into a body of water, the higher the pressure. This is because the deeper you go, the more water is technically on top of you. Because the deep waters are under such heavy pressure, that is, there's more water on top of them, the carbon dioxide of Lake Nyos is easily dissolved into the water and is safely contained within the deepest layers of the lake. But what would happen if something were to disturb these layers? What happens when you shake a can of soda? On August 21, 1986, a 1.6 million ton cloud of carbon dioxide rose above the lake at a speed of 62 miles per hour. Because CO2 is denser than oxygen, the cloud stayed hovering slightly above the ground and moved down nearby valleys towards several villages. The oxygen was displaced and carbon dioxide is not breathable, and as a result, 1,746 people were suffocated. The cloud was able to reach villages that were 16 miles away from the shores of Lake Nyos. People who survived the outgassing suffered from respiratory problems, skin lesions, and even paralysis. The death of wildlife and livestock was also devastating, with many villages relying on livestock and hunting for their livelihood. After the outgassing, the heavy concentration of iron typically confined to the bottom of the lake rose to the surface, turning the usually blue waters a deep shade of red. But what caused this disaster? What had triggered such an event in a lake that had been considered safe for years before? The truth is, the exact cause still isn't known. While many people think that an earthquake or a landslide caused the disturbance in the lake's waters, experts argue that it could have been something as benign as rain or wind. But for the sake of explanation, let's say that it was an earthquake. An earthquake that occurred under the lake would have caused the cold, deep layers of water to rapidly mix with the warm surface waters, like if you were to shake a can of soda. Because of this, the carbon dioxide that was formerly contained within the deepest part of the lake would be depressurized and rapidly rise to the surface, forming the gas cloud that would eventually suffocate nearly 2,000 people. The disaster was catastrophic, and scientists began scrambling to find a way to prevent it from happening again. The lake was degassed in 1995, when French researchers installed the pump that would lift water from the bottom of the lake, reducing pressure and releasing gas that was stored within the depths. Despite this disaster, the area surrounding the lake is being resettled. The land is considered ancestral by many, and the fertility of the soil is too much for some to pass up on. But villagers say that every time the waters begin to churn or the smell of the air changes even slightly, they remember that day in 1986 and the lives that were lost. And I hope that you do too.